Okay, guys, let's look at this question, how to answer electrostatic question. So this is from the past paper. So I'm going to try and move slow on this one so that you guys can understand how to answer electrostatic questions. Okay, so this is question 7 from November 2024, paper 1, question 7. So on this question, they say P is plus 2 nanocoulombs point charge and X is a 0.6 meter away. So I'm not going to waste time. I know that the distance in electrostatic, it should be in meters. And then now we need to convert this. We need to take the 6, we convert that from centimeter, and we need to put it in meter. So to do that, I'm going to divide that by 100. So my R, okay, let me just put this here. My R will be equals to 0.06, because we take the 6, we divide that by 100. We are moving from centimeter to meter. You know why I'm doing this? I don't want to make mistakes, because if you forget to do the conversion, you're going to be in a very big problem, and you're going to lose marks. So I don't want to lose marks. So the moment I see centimeter, I convert. And they say that point X is that 0.06 meter away from charge P, as shown in the diagram. You can see the diagram. And the first question, they want you to calculate the magnitude of the electric field at X. Okay, so if you just have to go on your formula sheet, look for under electrostatics, look for the formula that has E, because E for electric field. Then I'm going to help you choose the correct formula according to what you are given. So that's why it's easy to answer physics questions, and it's easy for you to prepare for physics exam. Look at this. They said calculate the electric field. So I have this formula for electric field and that formula for electric field. You need to choose the formula according to what you are given. Okay, so we're coming back to choose the formula. Let me just analyze the question first. So now look at what I have this side. I have the charge, right? So they say at point X. So I have the charge, and the charge is at point P. Okay, so I have the charge, and I can call that Q. So I'm going to do what we call data. Right, so I have Q, which is equals to my charge. It's 2 nanocoulombs. So I'm not going to include the sign when I calculate the electric field at point X. Please don't say plus 2 or minus 2. Just only write 2, and we need to convert that, which is another thing that I need to give you guys on this lesson, the conversions. Just in case you are writing this, just in case you are writing tomorrow and today you see this lesson. So these are the conversions. I'm just gonna quickly give you guys the conversion. Let's start with centi. So in most cases, centi, it will be cc. So if it's like this, you're going to take whatever charge that you are given, you multiply that charge by 10 to the power negative 2. Right. So another one is what we call milli. So if it's given in milli, you're going to see it like this. So it's going to be milli. You're going to see it like that. So if it's like that, we multiply by 10 to the power negative 3. So this will be 10 to the power negative 3. Okay. So another prefix that you can get is micro. So micro, you'll see it like that. So if it's like that, you're going to multiply by 10 to the power negative 6. Right. And another one is what we call nano, which is the one that is given on this question. So if it's nano, you need to multiply by 10 to the power negative 9. Okay. And the last one is pico. So if it's pico, you're going to see it like this. make sure that you memorize these conversions, right? You're going to take your charge, you multiply by 10 to the power negative 12. Okay, let's go back to our question. So this one is given in what? It is given in nano. So we need to take the 2, this charge here, we need to take that charge, multiply that by 10 to the power negative 9. So my charge, it will be 10 to the power, is 2 times 10 to the power negative 9. Okay, so now look at this. I have the charge and I have the distance r, which is equals to 0, 0.06. So since I have Q and R, it will be easy for you to choose the formula. You can go to your formula sheet. We don't have the electrostatic force, so we can't use that one. But we have the Q and the R, and we know that K is constant. So if I go up, they will also give you K. So K is this one. It's 9 times 10 to the power 9. That's K. It's a constant. It's a Coulomb's constant. So now I know the formula that I need to use. The formula is this one. This is the formula that I'm going to use to calculate that one. I'm sorry guys for going into too much details, but I hope this is helpful. Now, so to answer 7.1, I'm going to say that the electric field at point X is equals to K times the charge over the distance between those. So when I do my substitution, remember we said K is constant, and we saw that it was 9 times 10 to the power 9. We're going to multiply this by the charge, which is 2. We already converted that. We multiply that by negative 9. Close the bracket, everything divided by R. So our R, that's 0.06 squared. So this is your E. So you just have to put that on the calculator and see what is E equals to. So I'm going to put that information on the calculator. Let me see what we get. Okay, so this will be, please, I also need you to try and punch this correctly on the calculator. So this is the perfect time for you to practice. Also do this on your side. So this is multiplied by 2 times 10 to the power negative 9. Okay, let's divide that by 0.06. And this is squared. So when I say equal sign, I get my electric field as 5,000 nanocoulombs, but this is a very big number. Okay, it's fine. I can give the examiner the marker and say my answer is 5,000, and then the SI unit for that electric field is N C to the power minus 1. Okay, so now let me just try and also give the examiner this answer in scientific notation. So A will be, I can write this as 5, then multiply by 10. How many zeros do we have? 3 of them. Then this is in what? This is in scientific notation. Because most of the things when you work in electrostatic force, you should have them in scientific notation. Let's move to the next question. A point charge S with a charge of minus 2 nanocoulomb is placed 4 centimeter to the right of charge P. I'm not going to waste time. I need to convert that guy. I'm not going to waste time. Okay, I'm going to convert that guy and say this is 0.04. Divide that by 100. Put it in meters. So this will be 0.04 meter. Okay. And then now they say that, okay, we can see the drawing. They want us to draw the resultant electric field pattern due to charge what? Due to charge P and S. Okay, so guys, this one is also interesting. Let me explain how to answer this 7.2. This will be very quick. charge P is positive, and okay, charge P is positive. Let me put it this right. So charge P is positive and charge S is negative. So they said due to charges P and S, so you need to do for both of them, okay? So the electric field line, they're going to exit and enter the charges perpendicularly to what? To the surface of the charges, okay? So look at this. Uh, First thing first, the most important thing that you need to remember is that the field lines, they will point away from positive charge. So if this is positive charge, they will point away. So I'm going to draw a line like this, and then I can show with an arrow that we are moving from positive all the way to what? All the way to negative. I'm going to use arrows. So they move from positive to what? To negative. So I can keep on making the lines with the arrows. I can keep on making the lines with the arrows. So now now another thing that you need to understand is that uh, those filled lines, uh, they don't have to touch or cross each other. If they touch, they're going to mark you wrong, especially if you are in grade 12. If they touch, they're going to mark you wrong. So we are saying that they are coming out of positive, they're coming out of positive and inside towards negative, towards negative, you see, towards negative. Okay, so one last thing that I need to highlight on this question, which is also important, is that the field line must not touch the charges. So when I say they must not touch the charges, what I'm trying to say is that make sure that you create this as a boundary. They must not touch those charges, meaning that they must not go inside. Okay. Also pay attention on that. If you draw it like this, you are in trouble. You can't have something like this. So make sure that the field lines must not touch the charges. Okay, I'm sorry. The field line, they must touch the charges, which is this part that I just highlighted, but they must not go inside. Okay, so they must touch, because this is my charge. So they must touch that, but they must not go inside the charge. I hope you understand that part. So let's work on the last. Okay, this is not the last question. They said that a third point charge T is placed 2 centimeters to the right of S, as shown in the diagram below. Point charge T experience a net electrostatic force of 2.5 times 10 to the power minus 4 newtons to the left. We can see the drawing, and then they want us to state Newton's law in weights. Okay, so when you state Newton's law, if you don't know how to state Newton's law, I'm going to give you a tip. When you get in an exam, write down the formula somewhere. Newton's law, and not Newton's law, Coulomb's law formula. You write it down and say this is K times the product of the charges, and everything is divided by R squared. So you can define the Coulomb's law using that formula. The magnitude of the electrostatic force exerted by what? One point charge on another point charge is going to be directly proportional to the product of the magnitude of their charges, meaning that we are trying to say that F is directly proportional to Q1 and Q2. And then F is inversely proportional to the distance between them. That's electrostatic. You see, you can just define that using the formula. So I'm not sure if you guys want us to write the electrostatic the formula down. I don't know, but it's fine. I'm going to put the definition at the end of this lesson for that one. Okay, now we're going to work on another uh, interesting question, which is 3 point. What is this? question 7.3.2. 7.3.2. So 7.3.2, they say that what is the polarity of charge T? Choose from positive or negative. I know that when are you going to do guesswork and be like, oh, I feel like positive is the answer today, or I feel like negative is the answer. Then if it's your lucky day, you're going to choose the correct one. But please just don't do guesswork, okay? Make sure that you know your story. Okay, so now I'm going to help you how to answer this. First thing first, I need you to use what you already know. Okay, so you already know that when I have like charges, so if I have like charges, what happens? Like charges, they will repel. Okay, right. So like charges repel, and then unlike charges, they attract. This is you and your partner. You guys attract each other, right? Okay. So this one, they attract. Okay. So now, if you understand that, look at this. They say that the net electrostatic force is to the left. The net electrostatic force is to the left on T. Okay, so please let's make sure that we keep that in mind. And then let's say P is positive. We can see that the P1 is positive. Okay, this is positive, and then we can see that the S is negative. So this one is negative. Okay, right. And then T is unknown. This is what we are finding. We need to find if P is positive or negative. I need you to focus on the direction of the net force. So you are told that T experiences a net force to the left. Okay, so this is what you are told, that P, it experiences the net force to the left. The final answer must explain why the force is to the left. So the final answer will explain why the force is to the left. So now we know that T is 2 centimeter from S. We can see that it's very close. Okay, so T is very close to S than to P. So T is 6 meter because we added the 2, the 6 and the 2. So P is going to be 6 centimeter from P. So T will be 6 centimeter from P, further away. I hope you understand that part. So the closer the charge has a strong effect. Which one? Which is S. So the one that is close is going to have a stronger effect on T. So charge S is the one that will have the strong effect on T. Okay, so S will dominate the force on T. I hope you understand. S, we are saying that S will dominate. Guys, I'm not going to say that this is 1 mark. I'm not going to explain this. I need to explain this. Né? S will dominate the force on T, because if I don't explain this, you'll get it in a multiple choice, which is 2 marks in a multiple choice. Okay, so now what you're going to do next when you have this, you're going to analyze the interaction between S and T. So now I need to ask you, if T were positive, what will happen? Let's say if P were positive, what will happen? We know that we are comparing T and S. We know that this will be opposite charges. There will be attraction. This will move in that direction, and then this one will move in that direction. Okay, so T will be pulled towards S, which is to the left. You understand? Which makes sense to the statement that was given. The net force is to the left. So this tells you that T is pulled to the left, only if T is positive. Okay, so now if T were negative, these charges are the same. So since the charges are the same, there will be force of repulsion. then this one will go in that direction. So this tells you that T will be pulled away from S, which is to the right. This is wrong. The correct one is the one that will give us the force that is going to the left. So now what I'm going to do, the final decision is that since the net force is to the left, S should be negative. So the correct answer, oh, I'm sorry. So to answer the correct answer, T must be positive, okay? So T must be positive. The correct answer is positive. That's your answer. Okay, so let's work on the last one. So what I can give you guys is that if the charge, okay, it's fine. Let me leave that part and work on that 5 mark. Calculate the magnitude of charge T. Oh, look at this. Charge T. And if they want the magnitude of charge T, this has to do with what we are referring to. How can you approach this question? So, this is the net electrostatic force and is going to be calculated by the vector addition. Okay, the vector addition of electrostatic forces that are acting on charge P. So I'm going to draw a free body diagram on and indicate all the forces that are acting on P. So please make sure that you pay attention on that. So let's say this is my T, and I can see that T we set is positive. Let me first compare T with S. S is negative. So if I draw my free body diagram, I'll have a force that is going in that direction on T. This is the force that I'm only interested in. Look at this. This is force of attraction, force of attraction. So the one that is acting on T, this guy there is the one that I'm interested in. And we're going to call this the force of what? Is going to be the force of S on T is the one that we are looking for. So it's going to that direction. Then I'm not going to be interested on that force. Then I need to compare T, which is positive, with what? With P, which is also positive. So this will give me what? The force of repulsion. This in that side, this in that side. I'm not interested in that one, but only the one that is acting on what? On T. So this tells you that another force that is acting on T is this one, and we're going to call this the force of P on T. Right. So now that you understand how I got my free body diagram, let me explain what will be the magnitude of charge T. Because we are saying that the what is this? We are saying that the the net electrostatic force is going to be calculated by the vector addition. So if I choose direction, maybe I can take right as positive or I can take left as positive, right? So it's up to you what you need to take as positive. So let's say I take left as positive, or even if you don't choose direction the way you do in Newton's law. So you can just know that these forces are going in different direction. The forces are going in opposite direction. What will be the F net? The F net will be the force. We can take the force of ST, and then, which is this one, you subtract the force of PT. So this is what we need to calculate, right? So I'm going to first calculate the force of, what is this? Let's first find the force of, I'm going to first find the force of ST, which we're going to use the formula K of the two charges over R squared. So if I do the substitution, we know that K is a constant, which is 9 times 10 to the power 9. And then charge 1 is the one for S. Look at charge 1 is the one for S, which was given as 2 nanocoulomb. And we said that if it's nanocoulomb, how do we do the conversion? Multiply that by 10 to the power negative 9. So this will be, let me see, this will be into multiply by, guys, I think if I do this now, let me just rewrite my equation so that you guys can look at this. The force of ST, so this will be K times the charge of S times the charge of T. If I write it like that, you're going to have more understanding of what I'm doing. So the charge on S, it was 2, and we need to take the 2, multiply that by 10 to the power negative 9. This is the conversion. We don't have the charge T, so I'm going to leave this as Q of T. This is what we are looking for. Q of T, divide everything by the distance between ST. So the distance between ST is 2 centimeter. Then you convert that to meter, which will be 2 divided by 100. It's equal to 0.02. So this will be 0.02 everything squared. Okay. So if you like, you can just leave your answer like this for now. Then let's go and work on, let's go and find the force of PT. So this will be K times the Q of P. We're going to multiply that by the Q of T, divide by the distance between them. So K, we know that 9 times 10 to the power 9, and this is multiplied by the charge P. The charge P is given as 2 also, but it's positive. Remember, we said we don't include the negative and the positive. You can see that when I calculate the electrostatic force, I did not include the negative and the positive. I just said 2, which is the same thing that I need to do now. I don't have to include the positive and the negative. So this will be 2 multiplied by, converted that, it will be 2 times negative 9. We don't have the charge T, so I'm just going to leave that at QT. Everything divided by the distance between them, between PT. So the distance between this P and T is the sum of 4 plus 2, which is 6 centimeter. When you convert that, we get 0.06. So this is 0.06. Please keep in mind that when you convert, you divide by 100. From centimeter to meter, divide by 100. Okay. So I think now when I have this, sometimes it might be difficult for you to work with this type of questions, right? It might be difficult for you to work with this type of question, but let me show you what you need to do. First thing first, we said that F net is equals to the electrostatic force that S exert on T, we minus the electrostatic force that P exert on T. Then already we know this. I'm just going to do my substitution here. There are many ways that you can choose how you want to do this. Né? So I'm going to take this part here, and I'm going to put it here. So first thing first, I can also substitute F net. If you go back, we were given that the F net is 2.5 times 10 to the power minus 4. That's my F net. 2.5 times 10 to the power minus 4 is equals to the electrostatic of S on T. That's 9 times 10 to the power 9. I know, too much work, right? But we need that 5 marks. So let's just work on this one. Minus 9 and then QT. Then everything is divided by 0.02 squared. I'm going to subtract that force of P on T. So this will be 9 times 10 to the power 9 into 2 times 10 to the power negative 9 times QT over 0.06, and this is squared. So I know that someone out there is saying, say, take out the common factor. Say, can we take out the common factor? Yes, we can take that QT out as a common factor. Then we punch that on the calculator, guys. I don't have much space, so I guess I'm just gonna skip some of the problems. So what I'm trying to say is that I'm going to remove this and that as my common factor, and then I'm going to take everything, punch that on the calculator, and then I'm going to have qt outside. Let me rewrite this equation here. I'm very sorry about the space now. So I'm just gonna rewrite this. Okay, so the F net is 2.5 times 10 to the power minus 4. It's equals to, I'm going to take the qt outside, then I'm going to remove that on the equation. But don't do this when on your side. Just make sure that you follow all the steps. So the answer that we get, we need to divide both sides by that answer to make qt subject of the formula. Right. Let's try and put that on the calculator and see what we get. Hopefully, we're going to put it correctly. Okay. Let me see. I have the bracket, then into 9 times 10 to the power 9. Then close the bracket. This is multiplied by 2 times 10 to the power negative 9. I'm just praying that we don't get an error. So everything is divided by 0.02 squared. And then I'm going to put the negative sign there. Then I'm not sure if I should put that other bracket inside the bracket. I don't know, but it's fine. Then this will be 9 times 10 to the power 9. Let's see, this is multiplied by the reason I put the multiplication between my brackets is that I'm avoiding to get error times 10 to the power negative 9. Okay, let's close the bracket and divide that by 0 0.06, and this is squared. If this gives us an error, I don't know. Okay, let's close the bracket. I'm not sure, did I even? Okay, it's fine. Okay, this gives us 4,000, right? Is that 40,000? So if this gives us 40,000, we need to take the 2.5. We need to take that 2.5 times 10 to the power negative 4 to the power negative 4. So equal, we need to take that and divide that by the answer. Divided that by the answer. I'm just going to put the answer inside the bracket, or I can just put this 2.5 inside the bracket because we are making qt subject of the formula. What is that equal to? This gives us 6.25 times 10 to the power negative 9. Therefore, the charge on q2 is 6.25 times 10 to the power negative 9 coulombs. Just a quick revision of what we did here. We just divided both sides by, remember, let me just quickly rewrite everything down there so that we are on the same page before we end the lesson. So what we have inside the bracket is 40,000. And then this 40,000 is multiplied by QT. You understand how the QT got there? We just had QT out as a common factor. Then this QT is equated to 2.5 times 10 to the power minus 4. Then you divide both sides by 40,000, divide that by 40,000 to make QT subject of the formula. This cancels, and when you punch that on the calculator, this is what you get. So there are more ways that you can answer this question. It's up to you how you want to do this one. But I think this is the easiest method when we use the vector addition. So since they are going in an opposite direction, we subtract. Okay, we subtract. So in other cases, you'll find that you have a free body diagram like this. They go in the same direction, then you add. And that's it from me. This is where I'm going to stop on this question. I hope you guys had it a great one. I hope you enjoyed the lesson. If this is your first time watching the lesson, please make sure that you share the lesson with your classmates. Also join the family by subscribing to the channel. Thank you guys. Hoping to see you on the next one.